Let's get started reviewing you for your test. Okay, so we're going to start with 1.1. The R1 and R3 are at the very end, so it's not quite in order. When it says we want to simplify an expression, that means you're going to distribute if you have parentheses, and then you're going to look and see if you combine like terms. Okay, so if I'm distributing here, I know I've got to take this -3 and multiply everything in here by that -3. So that gives me x minus 3x to the second. -3 times -x is a positive 3x. -3 times 2 is a -6. Now, like terms, of course, remember they have the same variable and the same exponent. So I'm going to be able to combine the 1x and the 3x. And I like to put things in descending order, which we'll talk about later, but we're going to start with the largest exponent. So this becomes -3x to the second plus 4x minus 6. And there is your result. For b, I know I have to distribute twice. -3 times everything in here, +5 times everything in here. So this gives me -3x to the second minus 6 plus 5x minus 5. And then I look for like terms. Okay, I've got a -6 and a -5. I can't combine these because one's to the second power and one is not. So I have -3x to the second plus 5x minus 11. Okay, I want to write a mathematical statement that models this statement in English. I've got to translate it to the language of mathematics. So instead of saying Sean and Tasha, what I want to do is I want to assign those variables letters. So I'm going to let S equal Sean's age and T be Tasha's age. Those are the unknowns. Okay, so now it says that Sean is. So S equals 12 years younger. Okay, so that means I'm going to have to start with something, and if it's 12 years younger, that means I'm going to subtract 12, and it's 12 years younger than Tasha. So Sean is equal to Tasha minus 12. Sean is the younger, so if you take Tasha and subtract 12, you get Sean. Okay, Joan earns 6 times as much as Eileen. So again, we're going to let J equal Joan's earnings and A equal Eileen's earnings. So Joan earns, that's the same thing as saying Joan is. So J equals, and if I have 6 times as much as Eileen, then that's just 6A. Okay, so if I have twice the sum of A and B, I don't need to do anything. I know A and B. But let's think about what this says. It says twice the sum. So that means I have to add them together and then multiply it. So I'm going to multiply twice, and then the sum of A and B is A plus B, which means I would add them together first and then multiply it by 2. Okay, for the following, set up an equation to model the statement, do not solve. Okay, so don't bother solving it unless it asks you to. So 11 less than 3 times a number is 19. Let's let n equal a number. Okay, so I'm going to start out with 11 less than. That means I'm going to subtract 11 from something. So it's 11 less than 3 times a number. And then is 19 equals 19. Okay, the quotient of a number in 20 is 45. So this time let's let x equal a number. So the quotient, remember that a quotient is the result of division. So a quotient, I'm going to put a fraction bar. The quotient of a number and 20 means I'm going to take a number divided by 20 is 45. Is equals 45. Okay, 6 times the sum of a number and 5 is equal to 50 more than that same number. Okay, so let's let n equal a number. I'm not very creative about my variables. Okay, so 6 times, so 6 times the sum of a number and 5. So I'm going to have my number plus 5, sum is the result of addition, equals 50 more than the number. That means I'm going to take the number and or which is n, sorry about that, plus 50. So that's an n. So let's solve some equations. We want to solve and then classify as conditional, identity, or contradiction. We want to remember what each of these mean. Conditional means there is one solution. There is one value of the variable that makes it a true statement. And identity means there are infinite solutions. Any real number will make it a true statement. And a contradiction means there is no solution. No matter what number you try in there, it will never be true. Okay, so if you end up with x equals a number, it's conditional. If you end up with something that's always true, then it's an identity. If you end up with something that is never true, then it is a contradiction. Okay, so if I have negative 1.2x equals negative 0.36. All right, to get the x by itself, the only thing I have done is multiply it by negative 1.12. So I'm going to divide both sides by negative 1.12. And that gives me that x, and if I'm rounding it to 2 decimal places, I'm going to have to use the approximation symbol. And 2 decimal places means 0.32. Since there is one solution, this is conditional. Okay, if I have 2/3 x equals -8, well, to get rid of this, I can divide by 2/3, which is the same thing as multiplying by its reciprocal. So I'm going to multiply by 3/2. Well, anything times its reciprocal is 1. So that just, all of that cancels out. And I'm left with x is equal, if I multiply this out, this is -8 times 3 divided by 2, which leaves me to x is equal to -24 over 2. So x is equal to -12. Since there is a solution, this is also conditional. Now they call it conditional because it is only a true statement if x equals -12. If you put any other value in there for x, it is not a true statement. So this is a solution, but there's only one thing that does it. Okay, so here we've got one that has fractions, and by overwhelming response, we want to get rid of those fractions before we solve this. So I'm going to look for the least common denominator. The LCD is 6. That means I'm going to multiply this entire equation by 6. Okay, so 6 times 1/3 gives me 2x. 6 times 5 is 30, and 30 divided by 2 is 15. 6 times -2 is -12x. Okay, so you want to get all the x's on one side. I like to have them on the left, but I notice if I move it over here, then that just tells me the only x's are over here. So I'm going to subtract 2x from both sides. That gives me -15 is equal to -14x. To get the x by itself, I divide both sides by -14. When I do that, I get negative divided by negative is a positive, so that is 15 over 14 is equal to x, or x is equal to 15 over 14. Since we have an answer, we found a value of x that makes it true, that makes this conditional. Okay, got another one with fractions. All right, so that means I'm going to have to clear these fractions. The LCD is 15. So that means I'm going to multiply everything by 15. Okay, so if I have 15 over 1 times 2x minus 3 over 5, that equals 15 over 1 times x over 3 minus 15 times 1. Okay, so if I take 15 and divide it by 5, that gives me 3. So that's 3 times 2x minus 3. 3 goes into 15 5 times, so that equals 5x minus 15. So now I distribute. That gives me 6x minus 9 is equal to 5x minus 15. Let's get the variables on this side, so I will subtract 5x from both sides. So that gives me x minus 9 is equal to negative 15. I'm going to have to go up here where I add 9 to both sides, and I get x is equal to negative 6. Again, this is conditional. Okay, if I have negative 3x plus 4 equals negative 3x minus 4, let's add 3x to both sides. And when I do that, I get 4 is equal to negative 4. This is never true. This means there is no solution, which means it is a contradiction. So if you're asked for a solution, the solution is no solution, but that means it's a contradiction. Okay, so here I've got to, this is too much. I've got to pare it down to something. So I'm going to multiply everything here by 2. So this gives me 2x minus 6 is equal to 3x minus 2x minus 2. Okay, then I'll combine my like terms here. That gives me 2x minus 6 is equal to x minus 2. I want to get the x's together, so I'll subtract x from both sides. That gives me x minus 6 is equal to negative 2. To finally get the x by itself, I add 6, and that gives me x equals 4. Since I have a solution, that makes this conditional. Okay, so my next one here, I'm going to distribute again. Oh, this looks very much like the last one. All right, let's see what happens. So this gives me 2x minus 6 is equal to 5x minus 3x minus 6. Okay, so I can combine my like terms here. That gives me 2x minus 6 is equal to 2x minus 6. This is always true. That means your solution is all real numbers, or you can say infinite solutions. And so this is your actual solution set. But because they're infinite solutions, this is what's called an identity. Okay, let's solve some formulas and we'll do this and finish up this video. Okay, so solve for y. That means get y equals some expression. So that means I have to get rid of everything over here on this side. Okay, so the first thing I'll do is I will subtract 2x from both sides. And it wants it in this form. So that means I'm going to have to put the x term first. So when I do that, I get negative 5y is equal to negative 2x plus 10. Okay, I've got to get the y by itself, which means I'm going to divide everything by -5. That gives me y equals -2 divided by -5 is a positive 2/5 x. 10 divided by -5 is -2. And it's in the appropriate form. Okay, so here's the formula for the area of a triangle. Solve it for h. So that means I want to get h equals and some expression on the right. So if I start out with a equals 1/2 bh. Now I can do this in one step or I can do it in two steps. Let's say I want to get rid of the 1/2. Then I will multiply by 2. So I end up with 2a is equal to bh. Okay, I want to get the h by itself now, so I'm going to divide by b. Since it was multiplied by b, I'm going to divide by b. So I get 2a over b is equal to h. Or I can write it as h equals 2a over b. Either one of those is fine. Okay, so we've got a formula to convert temperatures from degrees in Celsius, degrees in Fahrenheit. So Fahrenheit is equal to 9/5 centigrade plus 32. Solve this formula for C. Again, that means I want C equals and some expression. Okay, so I've got to get the C by itself. So the first thing I'm going to do is subtract 32 from both sides. So I get F, oops, and that's minus, I'm sorry. F minus 32 is equal to 9/5 C. Okay, so now I'm going to get rid of the 9/5, and to get rid of a fraction, I multiply it by its reciprocal, which is 5 over 9. And I'm going to have to do that to both sides of the equation. So that tells me that 5/9 times F minus 32 is equal to C. And it doesn't tell you what form you have to leave it in. You've got C by itself, so that's absolutely okay. We'll stop here.